So, guys, our today's topic is about the latent heat and the sensible heat. So, today we are going to discuss some important points regarding to the latent heat and the sensible heat. So, in this, we will discuss some topics regarding to latent heats and the sensible heat and the latent heat. We will discuss the concept about the sensible heat, and then we will discuss some important points regarding the latent heat. Then we will discuss the enthalpy change of water, so means the how ice is changes into vapors or superheated vapors. Then we have this small problem on the rate of cooling. So first of all, we are starting with the sensible heat. So what's the sensible heat? So from the name sensible, you can understand that it can be sensible, means it can be measurable. And the definition is that when heat transfer cause the change in temperature, it is refers as the sensible heat. So that means when we transfer the heat from one in particular substance, so in that case its temperature will increase but its phase remains same. So it's a measurable quantity. For example, we are taking the it's not water boiling. Let us take the example of the water. So suppose we have the water and we are heating the water. So before heating, its temperature was we can say the 15 degree centigrade, or not 15 degree centigrade, 25 degree centigrade. I'm talking about the 180 amp pressure. And when it reaches to the 99 degree centigrade, after 99 degree centigrade it boils. But when it reaches from 25 to 99 degree centigrade, the heat added will be the sensible heat. Why? Because we can measure the change in temperature. We can measure with some thermometer or some thermocouples are employed for this, so we can see the change in these temperatures. And you can see the water is remain at 25 in a liquid state, and it remains same in the liquid state at 99 degree centigrade. So this was this was about the sensible heat. So formula for calculating the sensible heat is the Q is equals to mcp delta T, change in temperature, initial temperature minus final temperature, and Cp is the specific heat of the water, and m is the mass of the water, whatever you may choose. Like specific heat of the water is 4.18, and mass maybe take 1 gram, and temperature whatever you choose. So so this is about the sensible heat. So now we are discussing the latent heat. So what is the latent heat? When heat transfer cause change in the phase, it's called the latent heat. It's a non-measurable quantity and no change in temperature. So it's not a measurable quantity. Why? Because in this the temperature of the substance is not changing, only its phase is changing. um, we know that there are three states of the matter: solid, liquid and gas. The solid can become the liquid and the liquid can become the gas or the vapors. So in this there will be the only phase changing and the temperature remain constant. No change, there will be no change in the temperature. And you can see this is the ice, it's in the solid form, and it became liquid water when heat is added. And then further heat is added, then it becomes the steam or the gas, we can say. Sorry, it's become the gas. So in sensible heat and latent heat, heat may be added or it may be removed. When ice become water, so the heat is so now you can see the heat is adding in the ice. And when the water becomes a solid or the ice, so you can see the heat is extracting. We extract the heat from the liquid to lower its temperature, so it will become the ice. So similar example of the water boiling, like this ice, water boiling, no, you can say this about water boiling, the ice become the liquid, and liquid become the gases, and further these gases become the superheated gases or the vapors. The formula for calculating the latent heat is equals to Q is equals to mhs minus hf, heat of sublimation we can say, and heat of fusion, which is equals to the m into hfg. This hfg is called the latent heat. So we can write this formula as Q is equals to m delta H. So in this, the only the enthalpy of the substance is changing. So this was about the latent heat, and we cannot make the latent heat, so we can observe the latent heat, like when we see the phase is changing and the temperature remains constant, so we can say that it is the latent heat. And when the only temperature is changing and the phase remain constant, so we can say that it's the sensible heat. So here we have some types of the latent heat. One is the latent heat of fusion, delta Hf, latent heat of vaporization, latent heat of condensation, latent heat of freezing. So what is the latent heat of vaporization? Means that latent heat of the fusion. What do you mean by the latent heat of the fusion? It is the heat contents required to change solid into liquid, that is called the latent heat of fusion. When solid is converted into liquid, so the amount of heat that required is called the latent heat of fusion. We can say if we want to convert the solid into liquid, we need the latent heat of fusion. And then we have the latent heat of vaporization. From the vaporization, you can understand there will be the vaporization phenomena, vapors will be formed. So similarly, the definition of the latent heat of vaporization is that heat added to change the temperature, to change the liquid into vapors, to change the liquid into vapors is called the latent heat of vaporization. So we can say it is amount of heat required to change liquid into the vapors. So then we have the latent heat of condensation. Condensation is the phenomena of making gas into liquid, so it convert these vapors or gas again into liquid. So we can say that the amount of energy required to change the vapors into liquid is called the latent heat of condensation. Remember, I am talking about the heat contents, not about the temperature. Okay, only the heat contents, these are in BTUs. Okay, so then we have the latent heat of freezing. So in this, the liquid is becoming into solid and the liquid water, so we can say that latent heat of the freezing is that the amount of heat contents required to change the liquid into solid. This is a something like story, like uh, we are converting the solid into liquid, then we have the latent heat of fusion, and when we convert liquid into vapors, then we have the latent heat of vaporization, and when we are converting vapors into again liquid, we have the condensation, and again the liquid into the solid, we have the latent heat of freezing. So There are other definition of the latent heat of fusion and the latent heat of vaporization in term of the molecules, or we can say the definition on the microscopic level. On the molecular level, we can say the latent heat of fusion, that energy is required to stretch and break the spring between the molecules. These are the molecules. There are some spring between them. These are the springs. These are different molecules, and these are the springs. So what is the latent heat of fusion? Is an amount of energy needed to stretch these springs permanently. Means if the spring is in that much length, suppose, and the amount of heat needed to stretch permanently these spring, means it will now become the wider, it will be the stretched. So the heat required to stretch that spring is called spring between the molecules is called the latent heat of fusion, and the energy required to break these springs, now it's not stretching, energy required to break these springs, now the springs are broken down, so that energy will call the latent heat of vaporization. As we know that there is a free forces between the molecules, between the molecules, and there are greater forces between the solids and lesser forces in the liquids and more or less in the gases. So this was about the latent heat types. So as we know that all substances have their unique latent heat of fusion and the latent heat of the vaporization. Different substances have that different latent heats. So the water, its melting point is 0 degrees centigrade and its latent heat of fusion is 333 joule per kg, and its boiling point is 100, and its latent heat of vaporization HF is 2260. You as a chemical engineer, you must know the latent heats of the water. You must know this latent heat of water at least. And then we have the for aluminium, for copper, for gold, for mercury, for nitrogen, for oxygen. So you can see there are different melting points, different heat of fusions, different heat of vaporization, and the boiling points. In next lectures I will give you some I will provide you some difference in boiling point, in melting points, what's the phenomenon of boiling, heating, melting, evaporation, and like these small concepts that we encountered in our daily life. So this is now about the enthalpy change of water, how the enthalpy changes in the water, means water is, how the water enthalpy changes. So there are some steps that how the water how the ice becomes vapor. There are 5 steps for making ice into vapors. Number 1 is that first of all there will be the sensible heating of the ice that we can sense with the temperature, its temperature will be changed. Then there will be the melting of ice, and here the latent heat play a role. Then afterwards, meanwhile, we have the sensible heating of the water, again its temperature changes. Then we have the vaporization of the water, latent heat, the temperature remains same but the phase changes, liquid become water vapors. Then again we have the superheating of the vapors. In vapors, in this fourth step, there are 2 phases present. Number 1, the water is also present in the vapors, but in case of step 5, superheating of vapors, all the water contents are removed, now there are only vapors. So you can see that ice, it become water, and the water become steam, gas, or the vapors, and further there will be superheating of these vapors to make to remove the water content in the vapors. So they are the melting and evaporation we will discuss in next lectures, and freezing and the condensation, like these things. So in front of you there is a one diagram, and this diagram will be very helpful for you. It will make you better understanding, it will give you the better understanding about the latent heat and the sensible heat. This diagram is about the ice which become water. So now we can see there are two different scales of temperature, one is Fahrenheit and other is the centigrade. They are on the y-axis, change in temperature, and the heat contents which are in BTUs on the x-axis. So we can see when the ice was at here, the ice is at the 0 degree centigrade. So as its temperature increases, so here will be the sensible heat. Its temperature changes and it becomes 32 Fahrenheit or 0 degree centigrade. So from this 0 degree centigrade, again heat is continuously added. So in now here there will be the only change in the heat contents, but you can see the temperature remains constant. And further from the so from 16 to 160 BTUs are added to make the ice in to increase the temperature of ice into up to 32 degree Fahrenheit or 0 degree centigrade. So from after this, then there will again from 160 to again it will rise this line. So this line is called the sensible heat line. So in this you can see the temperature is changing, and from 32 Fahrenheit it become 212 Fahrenheit or 100 degrees centigrades. This was all this was about the water at 100 degrees centigrades. From now again the heat is continuously added. So now again there will be the latent heat, there will be only increase in the heat contents, but the temperature remains same, and the heat contents are added up to 1300. From 0 to 1300 heat contents will be added to make ice into liquid. So from this again it will form, again this temperature increases and it becomes the vapor or the steam. Then there will be again sensible heat line. So as when the solid melts, the energy added is building up the energy of the molecules, so they can break free of the forces between free of the forces holding them together. So from this you can understand that to make so here it is the vapor and here the water is the liquid. So you can say from 0 to 340 contents are added needed to make the ice into water, and from 0 to 1300 BTUs contents we need to make ice into the vapors. So this is the one diagram for the ice. So I have the one beautiful diagram similar like this for the ice in the next slide. So in this diagram, as you can see that similarly like before ones, but only in this there is no temperature values and no heat contents values, only there are A, B, C, D region. So as from 0 to this is the boiling point, okay, water's boiling point, water is heating, this is the phase A. After this water boiling to steams, so here it became to the steam, the total heat in the boiler. So from A to B region In A region there will be a sensible heat, in the B region there will be a latent heat of vaporization, and there will be the smaller region which is called the C. This is again the sensible heat. Superheating will be there of the vapors. Now the contents of the waters are removing, and from C region to D region there will be the steams. We form the superheated steam, and this region, in this region there will be the sensible heat. After that and then we have the total heat added by the superheater. So up to C region we have up to starting of the C region we have only the vapor, but in this there is a some amount of water, and again there will be the heating of the vapors, so it becomes the superheated steam, and in this the water contents are removed, only there are vapors. So this is the diagram similar to before, similar as before I showed you. So now we have the one problem on the rate of the cooling. In this the statement is given that 100 kg of ice at minus 10 degree centigrade is placed in a bunker to cool the vegetable. So to cool the vegetable, and after 24 hours later the ice has melted into water. So now the ice became water in 24 hours, and the temperature of that water is 10 degrees centigrade. So what is the average rate of cooling in kilowatt provided by the ice? So now we have to calculate the average cooling rate, in how much time there will be the how much cooling. So given data is that we have the specific heat of the ice, which is Cs, which is 1.94 kilojoule per kg into Kelvin, and the specific heat of the water, which is 4.186 kilojoule per kg into Kelvin. Then we have the latent heat of fusion of ice at 0 degree centigrade, which is the 333 kilojoule per kg. And now this is the solution. So in this, first of all we have to calculate the heat gained by water, how much water how much amount of the heat the water gains. So it will be calculated from Q is equal to mq small q, then which is the m is equals to Cs. Now Q is replaced by its formula, which is Cs Ts minus T capital S. So in this Cs, as we know, it's the specific heat of the ice, and this is the SHG plus Cf Tf minus Tf. So now in this we have the capital T, and there is a smaller t, and there's the smaller s and the capital S. So in this we can see the value of mass is 1000 kilogram, and the value of the Cs is 1.94 kilojoule per kg into Kelvin, and the value of Ts, which was the initial temperature, which was the initial temperature, which was a 0, and then we have plus it is maybe then we have the minus, and when we place this 10 it will be the negative. So the negative become positive. So we have here 10 plus HSG, which is a 333 kilojoule per kg latent heat of fusion, and then we have the Cf, which is the 4.18 specific heat, and then we have the Tf minus Tf. Here the capital Tf is the 10, and the smaller Tf is equals to 0. So as from minus 10 to 0 to 10 we are taking these temperature ranges, and this is the formula for rate of cooling. So as we calculate this Q, then we will place this Q here, and we will put time in 24 hours. This is the time when we will divide, we will get the value of cooling rate, which is equals to 4.586 kilowatt. So this was a cooling rate that we found. Now you can do the calculation by yourself, and here the small ts is the 0 from 0 to here the capital is minus 10, so minus minus become positive, so 0 plus 10 there will be. So this was all about the latent heat of fusion, enthalpy changes of water, latent heat of vaporization, condensation, freezing, and about sensible heat and the latent heat. So I hope that you understand better. So this was about today's lecture. Thank you. Please subscribe my channel, so I will upload the more videos related to these key concepts. Thank you.